Yes, dear students, today we are going to revise covalent bonding with the help of revision checklist. Here, if you see revision checklist, in this revision checklist, first point we will find, state that a covalent bond is formed when a pair of electrons is shared between two atoms, leading to the noble gas electronic configuration. Okay, for example, if we see in the case of hydrogen, it has one electron in its only shell, that is one shell. The nearest noble gas is helium. It tries to get the electronic configuration of helium. By doing so, it shared electron with another hydrogen atom and get the electronic configuration of helium gas, that is noble gas like structure. We can show it like this line indicate bonding, that is a single covalent bond, means one electron is shared by each atom. In total it becomes two electron or one pair. So hope you are clear with it. Another example of covalent bonding is in nitrogen atom. In nitrogen atom we will see that there is a nitrogen molecule, there is a triple covalent bond, means three electrons shared by each atom. Each atom has 7 electron in total, that is 2 electron in first shell and 5 electron in last shell. So if we see the nearest noble gas is neon, it wants to get the electronic configuration of neon. By doing so, it will share electron with another nitrogen atom. For example, cross, 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 these 3 electrons. It also has 2 electron more in outer shell, and other nitrogen atom, dot, 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 and 2 dots here. We can show it like this way. Here I have shown it. So hope you understand why covalent bond is formed. Each bond is formed when atoms get the electronic configuration of nearest noble gas. What is the difference between covalent bond and ionic bond? In covalent bond, electrons are shared between non-metals usually, and in ionic bond, electron transfer from metal to non-metal. Here the next point is describe the formation of covalent bond in simple molecules including hydrogen, chlorine, H2O, CH4, NH3, HCl, CH3. Hope you will see this video and you may rather or practice these. I would like to show you another example here. This is, hope this is in front of you. In this, we can see that this is the dot and cross diagram for CH3OH, that is methanol. In this, if we see one carbon atom is bonded with 3 hydrogen atom, is shared 1 electron. Okay, each hydrogen shared 1 electron with carbon, and secondly, carbon has shared its 4 electron, 3 with 3 hydrogen and 1 with 1 oxygen. Okay, next is we can show it like this way. If we are going to draw outer electron only, C dot C, the electrons of carbon are shown with the help of dot, and electrons of other atoms are shown with the help of dot. Here another example of hydrogen chloride, HCl, H cross and chlorine dot. We can show it again like this way and this way. If you want to show all are correct. Here one thing I am noticing, dot, dot. Here it should be dot and it should be cross. Again it should be dot and it should be with cross. If it is cross, then all are of these are with the help of cross we have to show, and this is with dot. Be careful about it. Okay, now next what I would like to show you is what is the next point in revision checklist. In revision checklist, describe and explain in terms of structure and bonding the properties of simple molecular compound, low melting point and boiling points in terms of weak intermolecular forces. Okay, the point which is need to be noted. I used to say that why students of O level use word weak van der Waals forces. Here, if you see this line, specific types of intermolecular forces are not required. You student of O level, you don't know where there are what types of forces. So you have to use simple word intermolecular forces if covalent compound, simple covalent compound. For example, SO2, O2, this is a molecule, HCl. Why these have low melting point, low boiling point? These are simple molecular structures with weak intermolecular forces which break easily. Okay, and the B point is poor electrical conductivity. Why these are poor conductor of electricity? No free electron. Some student are used to say no free electron, no free ions, means you are not very much clear. So if in the case of covalent compound, simple molecular compound, we have to just say there are no free electron, no need to say ions or etc. Just free electron. Okay, the next point is giant covalent structure. One we have learned simple molecular structure. Here I have given many three examples. There are so many examples as well. N2Cl2. In contrary to it, what are giant macromolecular structure? The example is silicon dioxide, carbon, in carbon specifically diamond, graphite. These are giant macromolecular structure. Describe the giant covalent structure of graphite and diamond. In diamond, each carbon is covalently bonded with 4 other carbon atoms, so no electron free. In graphite, each carbon is covalently bonded with 3 other carbon atoms to form a hexagonal structure. If I can show you in the structure here, yes, this is the structure here. If you see this is the structure of graphite. If you notice, this is showing carbon. This dot is showing carbon. Each carbon is bonded with 3 other carbon atoms. 1 carbon atom, 2nd carbon atom, and this is 3rd carbon atom. In total, there are 4 outermost electron, 4 electron in outermost shell. That's mean 1 electron become free from each carbon atom. So this free electron help to conduct electricity. Whereas in diamond, this is the structure of diamond. In diamond, this is carbon atom, which is bonded with 1, 2, 3, and 4. Each carbon atom is covalently bonded with 4 other carbon atoms. You will notice that this is a network of many covalent bonds. That's why these are macromolecular structure, where contrary to it, this is a simple molecular structure. Just one bond between 2 atoms, or maximum triple covalent bond between 2 atoms. Maximum triple covalent bond, not many bonds. If many bonds, giant macromolecular structures. Is a limited number of bonds, limited number of atoms, simple molecular structures. Simple molecular structures have low melting point, low boiling point due to weak intermolecular forces. Whereas giant macromolecular structures have very high melting point. Why high melting point? To melt, to boil these, there is need to break these strong covalent bond. There is need to break these strong covalent bond, this strong covalent bond, this strong covalent bond. Covalent bonds are very strong. There is a common mistake. Students are used to say these are weak covalent bond. No, all bonds are very strong. Ionic bond, covalent bond, these are very strong. The forces are weak. Intermolecular forces are weak. Bonds are not weak. So why giant macromolecular structures have very high melting point? There is need to break strong covalent bond. Remember this statement whenever he asks in the exam that why diamond has very high melting point, why graphite has very high melting point. These have very high melting point because to melt them there is need to break strong covalent bond. And why HCl, nitrogen, hydrogen, oxygens have low melting or boiling point, and to break them, to break away from the molecule from each other, means these are weak intermolecular forces. Again, their covalent bonds not break. The molecules become far apart. These dots are intermolecular forces. These forces breaks and molecules go away, and liquid changes into gas, or solid changes into liquid at very low temperature. Here, if we see the question, the diagram shows the structure of two forms of carbon. Which set of data is correct for these two structures? Conduct electricity. Okay, which one can conduct electricity? Yes, obviously it is graphite. S. So B or C, it could be the option. Very hard material. Yes, very hard material is diamond. T is the example, can be used as a lubricant. Yes, why graphite can be used as a lubricant? Again, I would like to explain with the help of, you can see these are weak forces between the layers. Due to these weak forces, this layer, such types of, there are so many layers in graphite. These layers can slide over each other. So you can say this is a dry lubricant. Like I would like to give the example of carom board. If you spray or put some powder on the or a chemical on the carom board, the striker become very slippery. Same way, we can use graphite in many machines to make it lubricate, so parts can slide over each other easily. So it provides the surface. Hope you are clear why graphite is a lubricant. Simply, at O-level stage, we have to give the answer. It has a layered structures. These layers can slide over each other. Hope it is clear to you. Now, again, I would like to go to revision checklist. What revision checklist? Again, asking from us. If we see, we have done this. That is, describe covalent structure diamond. It is clear. Describe the giant covalent structure of silicon dioxide. Relate the structure and the bonding of the graphite and diamond to their uses. Limited to graphite, a lubricant, and as electrode. Okay, we have done it. Why electrode? Again, it has free electron from each carbon atom. Diamond in cutting tool. It is a hardest substance. It is used in cutting tool. Describe the similarity in properties between diamond and silicon dioxide related to their structure. Yes, if we see, I have shown you the structure of diamond. Please note, this is the structure of diamond. Again, this is the structure of diamond. Okay, and this is the structure of oxygen atom and silicon dioxide. Yes, this is the structure of silicon dioxide. Here, if we see in silicon dioxide, each silicon atom is covalently bonded with 4 oxygen atom, and each oxygen atom is covalently bonded with 2 silicon atom. Okay, that's why it is SiO2. Okay, here it has shown with the help of dots and dark dots. This is silicon. And if we notice, what is the similarity between the structure of diamond and silicon dioxide? Both have tetrahedral structure. Both have tetrahedral structure. Hope it is clear to you. Okay, next is, I would like to explain in bonding. We have done this. What is the glass is made from sand. Pure sand has a giant macromolecular structure, which is silicon dioxide. Explain why sand has very high melting point. Again, it is a giant macromolecular structure. To melt it, there is need to break strong covalent bond. Okay, there was another question which I would like to show you in this structure. Explain in terms of structure and bonding the difference between the melting point of these two. This is again, this there is need to break weak intermolecular forces when we have to melt this polyethylene, and there is need to break strong covalent bond. Whereas what I would like to show you, very high melting point here. Yes, So hope you are clear with what is the similarity between the structure of diamond and silicon dioxide. This is the structure of diamond, tetrahedral structure. This is the structure of silicon dioxide, or this is the structure of silicon dioxide. Here it is shown in both. You can see this is a tetrahedral structure. This is the asking of the examiner. Again, I would like to go on revision checklist what he is asking in yes, graphite, lubricant, metal. Next is metallic bonding. We will see this in next video. Hope you are clear. What if he asks about the melting point in simple molecular structure, in giant macromolecular structure? What are the similarities between diamond and silicon dioxide?